what we call your data. So I have uploaded the data in terms of Excel file. So yeah. So why did I put it in the Excel file? Because normally when you want to collect your data, you will have like, you will use your Google form. So in the Google form, you can actually generate the Excel file. So once you take it from your Google form, you will see something like this. Okay. So this is just a makeup data. Uh, I created it last night. I did have one data that I used for previous semester, but somehow because the iCarly was not working, so I couldn't retrieve the old one. So currently we use the new iCarly, so the old iCarly is not retrievable. Okay, so I created a new one. So this is just for the purpose of the exercise today. Okay, so the first uh, column, we can say this is like ID, your respondent's ID. So uh, less likely for you to ask the name. But why did I put name? It could be the ID of your respondent. It could be what else other than name? It could be emails, address. It could be postcode. It could be a house number. It could be well many other things. Okay, so sometimes you just want to put the ID so that you can somehow trace your respondent. Sometimes they don't really want to trace the respondent. They just put number, like uh, respondent number 1, number 2, whatever. So it depends. Okay, so I believe that many of you use email, so that will be the ID of your respondent. Gender. So this is just the demographic variable question that you will ask, because sometimes you want to see the difference between the performance of male and female, whether male perform better in terms of academic performance or otherwise. So you just want to see the difference. Okay, and we also have age. So this is what we call number or um, ratio variable. You can also have education. So in this case, I'm using like, I put it into in terms of groups, means that education, this is just an example. You may have like what, a bachelor degree, master or PhD, or maybe you're gonna have like primary school, secondary school, or whatever. Okay, so for the sake of our discussion today, let's because here I put number 1, 2, and 3. So let's assume number 1 is bachelor degree, number 2 is master, and 3 is PhD. Okay, so this kind of set of data is actually, let's assume that we are talking about IUM community. That's why you, when you look at the age, you're going to have 30, 36, 22, whatever, right? 50. If you want to take the age of students, normally I will not ask you, I will not recommend you to collect the age. Why is that? Because your age is has a very little difference. The gaps is like 20 until 24. So just 4 years, you cannot find the difference in statistics. You have to have a very large gap to see the difference between the age, like 22 and you compare it with 50, 55. So you can see the difference. But if they say just 5 years difference, no, you shouldn't take the age of the students. But if you talk about the IIUM community, so you are talking about the students, the lecturers, the staff, the admin staff, what else? Those who are working in cafeteria, those who are working in shop, and so they may have a variety of age, right? So in that case, you can collect their age. But if you are talking about students, don't collect the age. Okay. Um, why? Okay. So these two things are actually the same thing. You will see them in somehow a different number. So the second one, why? Normally in economics, when we talk about income, we will label it as Y. Okay, Y refers to income. So the second column is actually the incomes in its actual number. Okay, so someone may get 7,290 per month. Some will get 1,000 plus and everything. Okay, and YG is actually the incomes in terms of group. Okay, sometimes you it's hard for you to ask them how much did you get per month, what is your salary. So it's hard to ask this kind of question, and you may group it like whether they are under low income group, middle income group, upper middle income group, or higher income groups, right? So you can label it as ordinal, or you can also label it as ordinal in terms of range. Like the income is 2000 and below, 2001 and until 3000, 3001 until something. Okay, so you can have a group. Okay, so this is the income group. So I put it, normally when I do data collection, when I want to analyze my data, I love to make a variety so that later on, maybe when I want to use when I want to analyze the ratio variable, so I have the ratio. When I want to analyze using the ordinal test, then I have the ordinal. So I love to kind of having these two options, and then to check the consistency using different tests, because ordinal will going to use different tests, ratio going to use different tests. So if you have like different way of labeling the data, you can use different tests. Okay. Um, Next, this is just the introductions, the clarification, explanations about the data. Next, amount. Okay, you're going to see two amounts. So the first amount, amount B, waste amount before the intervention or before something has been done. Second is waste amount after the intervention. Okay. Let's assume that we are talking about the waste produced in RIUM by RIUM society. So everyone is producing waste, right? There is no one who will not produce waste, right? If let's say you want to purchase ice cream, you want to purchase chocolate, the chocolate will not come by itself like chocolate. It will come together with the packaging. It will come together with the plastics, right? So the plastics are the waste, right? So even though you didn't want to have the waste, but when you somehow purchase something, it will come together with the waste. So so you discover that, well, in RIUM, the community are producing lots of waste. So maybe you think that we should do something like doing campaign or programs so that we can increase the awareness of the community, right? So you do the campaign. So campaign is like intervention to reduce the waste, and then after the campaign, maybe you want to re re-estimate the amounts of waste to know that whether your campaign is effective or not effective. So you will do the first stage of interview. I mean data collection, where you will discover that how many waste that you have collected, that the society, the community will produce, and then you do the second time after the campaign and recollect the data with the same number of respondents, and then check whether their amounts of waste produced have reduced. Okay, and the last one is waste. This is like a dichotomous or binary variable. Like 0 means that you didn't produce any waste. Well, it's hard to believe. 1, you have produced waste. Okay, so far so good, right? So this is just the explanation about the variable, a few variable. Okay, now when you have downloaded the SPSS, you will see something like this. Put it in your desktop so that you can easily use it. Don't make it like me, because my desktop is very messy. I don't have time to clean it up. So you may see something like, if you can see my cursor, IBM SPSS statistic, and the number after that to show the versions of the SPSS. So double click on it. So it will take like about 1 minute, because SPSS is a very heavy software. But if you are using other software, it will, when you double click on it, it will appear straight away. But for SPSS, you will see some delay. Okay, to show that how heavy the software is. Okay, now then you will see this, right? They will tell you, welcome to IBM SPSS. Oh, don't worry about it. And then go to new data sets. Okay, can you? I hope that you can see my cursor. So click on it. Okay, because you want to create a new data set. Double click on it, basically. So you will see this. Okay. I will put it. There are two page, like two window that open to you. So the first one is like this one that you will see many table. The second one is the output. outputs. Once you perform an analysis or test, all the tests will appear in the output. So I will minimize this first. So let's go to our tutorial. I mean the steps. Okay. Maybe I have to make it like this. Can you still see the steps? Okay, I hope so. Okay. Okay. So let's start with our steps. So click on the downloaded file and then click on the new datasets. We have covered that. And then you will see the variable view. Okay. So under this so many table, you will have at the bottom, you will see variable view, the orange one, and the data view. Okay. So data view is all the data. Once you have inserted everything, it will appear in data view. So the variable view means that you have to insert. So if you look at the notes, in the variable view, you have to key in all the informations, all the data. Okay. So means that you have to label everything. So how many data? Tell me. Okay, let's put it here. So, so the first one, name. This is the names of the variable. So what is the names of our variable? The first one is we have names. Second, what do we have? Anyone? Gender. Third,
Age.
age. And okay. After age, tell me.
Education.
Oh my God, where did I put it? Okay. Oh, I somehow click on this. Click. Don't save. Currently my Excel file is having some. They asked for the update. I didn't update, so I cannot basically undo. So I have to close it first. Okay. Okay. This is the problem when you don't have time to fix everything. So gender, and then you have age, and then what else? Edu.
Education.
And then income group, and then income. What else? Amount. This is before the intervention. Amount after the intervention, after. And then waste. This is whether you have produced waste or not. Okay, cool. Okay, now maybe make it bigger to see this whole thing. Okay, type. This is the types of variable. Okay, so when you talk about ID or emails or postcode, whatever, you just want to trace the respondent. You don't want to analyze email, right? You don't want to analyze the means of the names, definitely. So if you don't want to analyze them, you have to click strange. Strange means that something that you just want to put it there to maybe there are some purpose, but you don't want to analyze them. Okay, for example, you want to know what are the factors that influence people to produce more pollution, to produce more waste. So you want to know the reasons for wasting lots of waste, for producing lots of waste. So you put strange. If you put numeric, means that SPSS will treat them as the data, then they will perform some analysis. So don't put numeric. Character. Character means how many characters. If let's say we have here a name, right? N-A-M-E. So there are 4 characters. Character can take in terms of alphabet or number. So some people will have a longer name. Some people will have a longer emails. So to be safe, you can put 30. It's up to you. It will go up to 30. Or you can put 100. This is 1,000. 100. So it is safety. Say okay. Put okay. And then, okay, so decimal. Okay, because you don't want to analyze names, right? So the decimal is automatically 0. But for other things, okay, I don't really like to have so many decimal. By default, it will appear 2 decimal point. But what I did, I copied 0, and then I put for everything, paste. So that everything will have just no decimal point. Okay. Label. Labels means that how you what sometimes when in your the variable name you put some short form, right? Like age is just fine. Edu instead of education. YG income growth. You can label them. Means that okay, education, or maybe here you want to put income groups, and so on. So label is not compulsory. If you want to put it, you can put. If you don't want to, it's up to you. Okay, so it is optional. If you know by if you see YG is income group, so you know it, so don't need to label it. If you think that you use so many short form and you need a label to remind you what are they, then put a label. Value. Value is only applicable when you are dealing with categorical variable or groups. For example, gender. Okay, so click the value. Maybe you want to put 1 to represent male, and then edit, and 2 to represent female. Remember, when you want to analyze something, you have to put everything into number. Okay, you can analyze in terms of alphabet, in terms of words. So you have to put number to add, and then okay. If you didn't click okay, means that you didn't save it. Okay. What else? Age. Your age currently in terms of number, so you don't really have to put the value. You will only put value if you have a group. Income group, definitely right. So you can put education. I forgot about edu. So edu. So first the value 1, maybe what is the level? Bachelor degree. Bachelor. So edit. And second, master. This is just an example, okay? Master. And 3, we have perhaps PhD. Edit, and then don't forget about to save. Okay. So you can just label income group and other things. Income, the second income is in terms of number. No need to put value, amounts. Okay, fine. So waste here, okay, you can also put 0 means you didn't produce or no waste produced. 1 means yes, you have produced some waste. Okay, so this is just an example. Missing. You don't really have to worry about missing because I'm assuming that you are dealing with a small number. You are collecting like maybe 30 observation, but in the real data, in the real data collection, normally we are dealing with thousands of data. And when you give the survey like consists of so many parts, part 1A, part 1B, part 1C, and then part 2, blah, 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 blah. So many items in the survey. So sometimes people are very lazy, so they didn't complete everything. They didn't fill up all the information. So you will discover some missing information, some missing data. So what normally the researcher will do is that they will put a number like if they click on it, they will put like this is no. If let's say you have a missing value, they will put 99 or 9. A different number that they use like 0 and 1 for waste, 1, 2, 3 for educations, right? So they will use a different number, 99 or 9, 69, whatever, to indicate the missing data. So whenever there is a missing value, they will put 99, and then SPSS will, when SPSS want to run a test, then when it see 99, or it knows that, oh, this is missing, so it will somehow automatically exclude that observation from being tested. Okay, so for your case, you don't really have to worry about it. Column, ignore it. Align, ignore it as well. Measure. This is what we call the level of measurement. You have learned it, right? So for name, by default, it knows, SPSS knows that it should be nominal, right? Gender. What is gender? Tell me. Ordinal or nominal?
Nominal.
Nominal. Sure. Age here we are talking about number. So number is scale, means that you measure it in terms of scale. Education. Where is it? Am I clicking education? Yes. Education is ordinal. Income group is also group, right? Income group is also ordinal. Actual income is scale. What else? Amount is also scale. Waste. Yes or no? Nominal. Okay, so this is the functions that you have learned in chapter 1. If you didn't understand chapter 1, you cannot do the measure. Okay, now save it. Okay, you want to save it, then it will appear. So you can save anywhere, desktop or whatever. So what should I write? What should I write? The file name? Any suggestion quickly? Or maybe you want to write workshop. Right. Save. So you can save whatever names you want to rename it. Okay, now. So we are done with variable view. Now go to data view. Okay, you can see that I'm clicking at the bottom data view with the orange color. So you can see that you have labeled them names, whatever, everything's here, right? So the next step is open the Excel file. Okay, so it's not that hard. What we call is that just copy paste everything from the name. Okay, I took only 30 observation. Copy and right click on it and then paste. That's it. Everything will be there. Okay, so I think so far so good. Okay, now let's look at our notes. So you have gone through the data view. So you have copy and paste done. Now is the analysis part. Okay, so the first test, we call it one sample t-test. Okay, you haven't learned this, but you will in the next chapter, which is chapter 10. Oh, I forgot to open this. Painting. This is how I open my painting. Okay, cool. Okay. What is it? Okay. So one sample test of hypothesis, which is this one. Okay. So what is one sample test? It means that okay, you have a population. This is your population, and then you take a sample from it, and this is what you call your sample. And then you want to know whether the means of the population is the same with the means of your sample. You want to know whether this is equal. Okay. So in the hypothesis, what is hypothesis? Anyone know about it? It is just a general claim. Like people say, that student is smart. That student is a very good student. That student is a very kind one. So it is just a mere claim. So just a statement. Whether it is true, not true, whether it is correct or not correct, you don't know. So in statistics, we never take any information as it is. We have to test it to make sure that that data, that information, that statement is statistically significant. Okay, so even though it is correct, but we want to make sure that the data, the information that we receive is statistically significant. So this is the example. Okay, it says that the mean cost to remodel a kitchen is 20,000. Okay, maybe your kitchen is not looking good, so you want to remodel it, you want to redesign it, and the cost, they said that the cost, the mean cost is 20,000. Okay, so it said the hypothesis saying that the claim saying that the mu is actually 20,000. So you collected a sample, okay, and then you want to see whether you will still get the same mean. Perhaps maybe you're gonna get the sample mean x bar is equal to 15,000. So you have to test whether 20,000 and 15,000 is statistically significantly the same or different. Okay, so this is what we are doing now. Okay, I'll close this. You will see this chapter later on. For today's workshop, we just want to know how to analyze it using SPSS. So, next steps. What should we do? Okay. I tried to make it bigger, but since it is available in your iTalib, so I hope that you can also see your own. Okay, so I also, if you look at these blue words or statement, It is just the definitions of what one sample t-test means. It compares the mean in an observed sample, which is the means in your sample. This is your x bar, to some predetermined or hypothetical value. This is the 20,001. So you want to compare your x bar with the hypothetical value, with the claim mean, okay? Or we call it predetermined mean. Okay, so what you need, this is what we call the rules and regulation. In order for you to apply one sample t-test, you have certain rules to follow. Okay, what you need, you have to have discrete or continuous variable. If you have categorical variable, you cannot use one sample test. Okay, so let's work on the steps. Analyze. Okay, so basically, do I have to, okay, yeah. You also have the output. Currently, you didn't produce anything, so you cannot see anything. But you can click the analyze in the output page or output section, or you can also click analyze in uh, the data view section. So you can, output will be there. I mean, not output. The analyze button will be everywhere, so you can just click anyone anywhere. Okay, doesn't matter whether it is in data view or variable view, the same thing. Okay, or in the output as well, doesn't matter. So now, the steps is analyze, and then you are comparing the mean, right? Compare mean, and then go to one sample t-test. So basically, when I click on this, I'm looking at the steps in the slide. One sample t-test. So you have certain things. What do we want to test? Let's assume that we want to know. Okay, maybe the hypothetical statements or claims saying that, okay, the mean age of those who are producing more waste is actually 24 years old. So you want to know whether, is it true that people with the age of 24 years old is the one who producing more waste? You want to know this. So we are talking about age. Remember, age is a discrete variable. Move it and click this arrow, and then the test value, maybe 24, because we are thinking that maybe the age of 24 is the one who produce more waste. So click 24. Okay, so all the steps are given here. You move the variable, for example, age, into the test variable. So when you look at this test variable, it is something like it's a section. So I bold it so that you know that it is there in the system, in the SPSS. Under the test value, you see test value. So I bold it. So you put any number that you want, right? So in this case, I just put 24 years old. And then click OK. When you click OK, it means that you ask them to run the test. So you will see the results. This is the result will appear in the output section. Okay, so I wanna minimize. Okay, cool. So basically, whatever you have, you get here is the same thing that I posted in your slide. Okay. Well, the same thing, 30N. Okay, let's just look at from here, because the one in the slide is very small. Okay, this one may be a bit bigger. So what do we have? So basically, this one sample test result is the second box. But why do you also get this the first box? So this is just, they call it one sample statistic. Statistic means that they give all the overview, the details about the variable. Now you are talking about age, right? So how many n? N here is the small n, not capital N, but in SPSS, because you will never test the population, so they put capital N to represent the sample n, the sample. So your sample is 30, the mean is 36.2. Remember, we put 24, right? So it is not the actual mean. Okay, it should be 36.2, and standard deviation and standard error of the mean. Okay, and this is the result. Okay, now you have many things to look at, right? The statistic, degree of freedom, significance, blah 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 blah. So how to read this table? Don't worry, look at the result. Result is how you want to understand how you want to read the table. Okay, the first one I mentioned one sample stats, one sample statistic, the first table, it will tell you the general overview of the variable. Second, one sample test, the second table. Okay, so currently you test the age of 24. So it means that the hash now, the mean age of IUM community who produce waste is actually 24. So, okay, so in hypothesis, you're gonna learn that you have to write hash null and hash one. What is hash null? Hash one is just the general claim, the 20,000 before, right? So in this case, our hash null, they said that, well, those who are in the year in 24 years old are the one who produce more waste. This is just an example. And H1 is your own claim based on the estimation. So you may say that, well, I write it in the words, right? Okay, so in statistic, we can also have the statistic word. So you can say the mu is equals to 24. So you may say that those, um, well, how to write it in the words. But in the statistic, you will write it mu not equals to 34. That means those who are in 24 years all produce more waste. And now you can see produce do not produce more waste. So do not means not equal. Okay. So let's just don't worry about these words because I'm afraid that you will get confused. So just make it simple. Mu, the first one is equal to 24, means that you are assuming those who are in 24 years old are producing more waste. And your H1, your own estimation, you said that 24 is not the one who produced more waste. Okay, so where is my cursor? Okay, now, then how to read the table? Look at the significance to tell. This one. Can you see my cursor? First column, second column, third column. Significance to tell. It is significant. You get a significant result. Okay. So what does it say? It means, okay, you can see here my cursor. I refer to the slide. It means that the result or the p-value, there is a difference between p-value and t-statistic. Normally, you learn how to compute t-stats, z-stats, right? Later on, you will learn f-stats. They will tell you the significance, but you're gonna compute it. But if you use this significant, the p-value, it will tell you straight away it is significant. Okay. So your significance is 0.000. It means that the result is significant. Okay. Uh, Other words, you reject hash null. So let me tell you a few things here. Okay. In statistics, your p-value, you will learn it in chapter 10. P-value, to be significant, it should be 0.05 or less. Okay. If let's say your p-value is more than 0.05, means that 0.6, 0 point something, right? More than 0.05, so it is not significant. Your result is not significant. Remember that. Okay, what does mean by 0.05? So this is what we call 95% confidence interval. Okay, if let's say your p-value is 0.01, this is what you call 99% confidence interval. You are confident that your estimation is correct. So that's why you're gonna have a very small p-value, because smaller p-value means that you are extremely confident. The smaller the value, the higher your significant level is. But if let's say your p-value is bigger, so your significance will be lower. In human science area, in like HS, political science, they can accept the p-value up to 0.10. 0.10 means that your confidence is actually 90%. They can accept that, but in economics, in statistics, we accept 95% confidence interval and above. For us, 90% is not good enough. It's not statistically significant for us. Okay, so let's stick to 0.05. Okay, now here you got 0.001, means that you are 99.9% confident that your estimations is correct. So it is significant. When it is significant, so you are saying that the hash null is not true. Yours is true. You means that you can, when your result is significant, you can reject the hash null, the general claim, the mere claim. Okay. Okay. So okay. So what else? Where are we going? It means that the result, the p-value is significant because you got 0.000. Means you have to reject your hash, the hash null, the general claim. So the means age of IUM community who produce waste is actually significantly different from 24 years old, because right now you are saying that the general claim said the mean is equal to 24, but actually you got a significant result. You said no, they are significantly different from 24. Okay, so that's how you interpret it. Where is my cursor? Mm-hmm. Yeah. Okay. Yeah. So you just have to look at the significant value. That's it. Okay. In the one sample test, this is what you want to see. So if let's say you try to put the mean age 36.20, your significant will not be significant. Your significant to tell here will give you insignificant result because that is the value. Okay. So another thing, if you want to know what is the mean age, okay, currently you assume like it is 24. It is not 24, right? If you want to know what is the mean age, what is whatever value that you want to know the mean, you can see from the one sample statistic, it is there. But another way, if maybe later on you want to test something and they didn't show, normally they will show this the whole things. But you can also look at from analyze, descriptive statistics, and then you click frequency, because in this you have many other things. For example, I click on age, okay? Click on statistics. Statistic means that this is the descriptions of your variable. In statistic, you will not only have central tendency, which is mean, you can have median, modes, or whatever, sum if you want to, quartiles, or whatever, standard deviation, variation. This is the measure of dispersion. You have learned it. Range. Maybe you want to see what is the minimum age of the IAM community, maximum, and then click continue, and okay. So you will see all these things. Oh, the minimum age is 21 and the maximum is 60. So you can see all these statistics, the descriptive, the value, I mean, the characteristics of your age variable. Okay, this is just example. So now let's try to put what is the mean age? 36.20. So what should I click? Analyze. Compare means we are talking about one sample t-test, right? So age, so test value, what is it? 36.2. Since this is the mean age, so your result shouldn't be significant. Okay, so I click OK. So look at here. Significant to tell, you got 1, which is not significant. You have to get uh, 0.05 and lesser. Now you didn't get the significant value. Means that the mean is 36.20. Okay. So far so good. So
Yes,
this is
madam.
the okay. 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 This I have explained this. Okay. Now next is the next chapter. We have covered chapter 10. Now we will move to chapter 11. Okay. What do we have in chapter 11? This is two sample tests of hypothesis. It is also hypothesis. You're gonna have a mere claim. Someone will claim whatever they want, right? It is your job to test, to verify whether that claim, that statement is true or not true. But now we are talking about two sample. Well, by its name is two sample, right? So previously we are talking about one population, and then you take the sample, then you want to check the mu, whether it is equals to the x bar, which is the sample mean. Now you have two sample, means that you have two population, population A and population B, and then you take the sample A and sample B, and then you want to know whether this x bar 1 and x bar 2 is equal. Okay, so sample A. So we are talking about two population, right? Two sample. You are comparing maybe this is like green apple and red apple. So you want to see the mean. So you take the sample mean from the population. Okay, so you check whether the means are equals or not. So in comparing this, you can compare something similar. Means that green apple, maybe green apple is a bit sour, whether people like it or not. And red apple, it is apple, but maybe it's a bit sweet. You cannot compare apple with durian, apple with orange. They are different things. The same case like, because previously I give the examples of fruit, so they cannot apply it to their data. The same thing, if you want to compare the income of primary school teacher and the income of the secondary school teacher, maybe slightly different, but because we are also talking about teacher, right? So you can compare these two things. There are similar things, but slightly different. You cannot compare the incomes of teacher with the incomes of maybe professional engineer. Income of teacher perhaps 3,000, and engineer perhaps like 20,000. You cannot compare something slightly totally different. Okay, you have to compare something quite similar. In the slide later on, you will see that they compare the incomes of technician and electrician. They are both having similar income. Then you can compare these two things. Don't compare something slightly different. Okay, then you will make a huge error if you did that. Okay, now under two sample test of hypothesis, we have two two tests. Okay, first one we call it independent sample. Second, we call it dependent or paired test. So now look at here. I'll close this. This is the independent sample, and you will look at the dependent later on. Okay. Okay. Now I also put the blue words to show what is it. So independent sample, this is from the two sample, right? Remember? Compares the means of one group to the means of another group. Basically, you are comparing two different groups, whether males or female, incomes of whatever with whatever. Green apple with the red apple. Okay? So what you need, this is the requirement or this is the rule. One categorical independent variable with only two outcomes, males or female, yes or no. What else? Fail or pass. What else? Head or tail, just two outcomes. You cannot have male, female, and something in between. If you have three outcomes, you cannot use this independent sample t-test. Okay? And one continuous dependent variable. So I'm afraid that you don't know what is independent and dependent. So dependent variable is here, and this is independent variable. So independent variable is like factors affecting the dependent variable. Let me give you the example, okay? Perhaps your dependent variable is CGPA. So you want to know what are the factors that affect the CGPA of students. So IV could be, independent variable could be the factors. Perhaps hours of studies. The more you study, maybe you will have a better GPA. Perhaps what? Difficulty of the subject. Um, perhaps what else? Perhaps the gender. Maybe a different gender will have different impacts on the CGPA. I don't know, right? So this is the independent variable, and the factors that will affect your dependent. This is independent. This is dependent. Okay. So now, so let's try to apply it. So I'm actually in the output section. Don't worry, you can just analyze from output anyway, as long as you can see analyze button. Make it smaller because I cannot see the steps. Well, in SPSS, you just somehow have to know the steps, right? So click Analyze, compare means because we are comparing the means. And now instead of looking at one sample, you are looking at independent sample t-test. Click on it. Yep. So what are the variables that we want to check? Okay, now we are talking about continuous variable. So what is it? The example, amount. This is the amounts of waste, right? Before the intervention. So drag it and put it in the test variable. And then you have to find one categorical variable. What is the categorical variable? Let's assume we use gender. Click in the grouping variable. And then you have to define it. Okay. So group 1 and group 2, because you have two groups, right? Remember, you have two outcomes. So what is in group 1? So in group 1, in my case, I put 1 as male. So just put 1. They just want, oh my God, they just want to see the number. 1 as male. And this is 2, 2 as female. Just put the number, 1 as whatever. Okay, and then continue. What else? Okay, don't forget to click OK. Then you will have the result. Remember, the first table is just the statistic, it's just the descriptions of your variable. You are talking about amounts of waste produced and the gender. You want to see this relationship. And then this is the independent sample test. You have such a very long table. Okay, so now how to look at it? You have so many things, right? Okay, now. So you will see the same table as well here, but because it is small, so let's just use whatever generated from the SPSS. Okay, result. Okay, I want to make it a bit bigger. I couldn't. Uh-huh. Oh. Okay, now it's okay. So group statistic table is just the same thing. Okay, independent sample test. Now, what you have to look at the significant value for Leven test. This is the Leven test. So you have to look at the significant value, which is 0.774. I put it here, 0.774. If significant value more than 0.05, which is not significant, right? So if it is more than 0.05, you have to refer to equal variance assume. You have to refer to equal variance assume, the first row here. But if the significant value is 0.05 or lesser than that, you have to refer to equal variance not assumed. So you have to take the value for the second row. Okay. So now we got 0.774. Which one? The first one or the second one? Equal variance assumes or equal variance not assumed? It is more than 0.05, right? So you have to refer to equal variance assume, the first row. Okay, then look at the significant total under the t-test for equality mean. So you have t-test for equality mean. If you can see my cursor, find the significant value here. Significant total, so you have to refer to first row, right? 0.609. Points, where is it? You have to refer to significant tel. Very significant. Yeah, I forgot to change it. This is the original one. Okay. Point. Where is it? 609. Why it doesn't want to go to this one? Okay, point. This cursor is not really like moving. So this shouldn't be, okay, I cannot even click on it. I don't know why. So this part should be 0.609. What happened is that I was using different sets of data previously. So I couldn't find it in the iTalim, so I have to recreate the data and recreate the slide. That's why it happens. So you should get the value for significant total under the first row is 0.609 instead of 0.003. But I couldn't change it here. I don't know why. Okay, so okay, so you have to take the first line, the first row here. Okay, because your Leuven test is not significant, which is 0.774. Okay, now, so how to interpret this result? So the interpretation is how you have to report it, how you have to formally present it in your paper, in your project paper. Because normally, when you want to interpret a statistic result, you have to follow a certain standard, like using APS style. So this is what the APS style says. You have to somehow report it this way. So how to report it? You will say, oh, it doesn't really change. See, I cannot even make it bigger. Oh, better. So it says, okay, so how you want to interpret it? An independent sample t-test was conducted to compare the amounts of waste produced for male and females. So there was a significant difference in the waste amount produced for male. So you have to, is it really significant? PPP is not. There was not a significant difference. Okay, so basically it is not, because previously they got the value of 0.03. That's why it is significant. So I was was see, I cannot even click on it to type not significant. Ish. Okay, so just to let you know that it is not, because the value is not 0.03. The value is 0.609. Okay, so there was not a significant difference in the waste amount produced for male, and then you have to take the mean for male, because we are talking about comparing the mean, right? So what is the mean for male? Mean 2265. So take the means of male and take also the standard deviation 2940, and then you compare with the means of female 1714 and take the standard deviation 2874. Is it correct? This is fine. And then semicolon, you have to put the T, because normally they will look at the T. So what is in the bracket of T? This is what you call degree of freedom. So where is degree of freedom? 28. If let's say your result, if let's say the significant in the Leuven test is not 0.7, is maybe lesser than 0.05, then you have to take the degree of freedom somewhere here, 27. But currently, because it is not significant, you have to use equal variance assume. So the degree of freedom is 28. Okay. And then what is the t value? T value 0.518. Okay, you put the t value and the p value. The p value is 0.609. This one. Okay, so the interpretation is somehow correct, except that there was not, you have to put not, because you got 6.609, which is bigger than 5%. And this one, I will try to adjust it. I don't know why I cannot adjust this. Okay, so that's how you want to interpret it in your paper later on. Okay, that is the independent sample t-test. Now we are going to the dependent, or we call it PET test. Why do I use two names? Because sometimes in the SPSS, they may not call it dependent, they will call it PET. So if I put dependent, you may not be able to find the button to run the test, right? That's why I put it both. Okay. So now, okay, so what you need? One categorical independent variable, for example, amounts of waste before the intervention versus the amounts of waste after the intervention. Okay, wait, let me see, 12. I want to explain what the dependent means. Okay, but somehow I'm checking the time. So, okay, this. This is the waste before intervention. This is the waste after the intervention. So you know that you have producing like a loss of waste. So you have an intervention somewhere in the middle, right? So you perhaps conduct campaign or perhaps programs or whatever to reduce the waste. And then after having the campaign, then you conduct the same, you collect the same data from the same respondent, and then you check the amounts of waste, whether it has reduced or maybe have no impact or maybe increase. Okay, so this is what you call dependent test or PET. PET means that you are taking the same respondent, and then you are comparing the difference between before intervention and after intervention. Okay, now what we need to do is okay, so make it smaller. So click everything, click analyze. You are comparing the mean, and then you're gonna see PET sample t-test. And then okay. So you are comparing two variables, so move these two variables into the PET variable, PET variable column. So we are talking about amount before and amount after. And then that's it, click OK. So you will see everything. So you just follow the steps, and then everything will be there. And then you will see how to read the results and how to interpret the result. That's it. Everything is there. I, I clearly put everything. So now, okay, let's make it bigger. Oh my God, we have so. Okay, so the first table always is the statistics of your variable. You're comparing before and after, and then you are looking at the means and blah, blah, blah. Second is just the correlation. The third one is the result for PET sample test. Okay, so how should we read it? So look at here. PET sample test. You look at the mean value for two variables. So you have 2008 for the amounts of waste produced before intervention. And after the intervention, if you can see my cursor, the amounts produced is lesser, right? Has been reduced to 1,665. Okay, so there was a decrease in the amounts of waste produced after the intervention. You can say that. This is how you want to understand the result. So if you look at the PET sample test, so what should we do? We always have to look at the significant to tell. Where is it? Here. Is it significant or not significant?
Not.
Okay. So as I mentioned to you, the p-value 0.05 and lower is significant. P-value more than 0.05, which is 0.6, or and above is not significant. Now, what is the significant value? You got it 0.034. 0.034. Is it significant or not
Significant.
significant? It is lower than 0.05, right? If you want to convert it into a confidence interval, confidence level, it's like 100 minus 34. So it's like 3. You are actually 98% confidence that your estimation is correct, right? Okay. So now, yep, you got a significant value, significant result. So, yep, 0.03, right? So how to interpret it? A PET sample t-test was conducted to evaluate the impacts of, so you want to see whether your intervention is efficient or not efficient. To evaluate the impacts of interventions on the waste amount produced by IUM community. So you can just add all the information. I put it a very short words because the space are very limited, and I don't want to put so many things so that you will get confused, right? So I just put the main point. There was a statistically significant decrease in the waste amount produced by IAM community before the intervention. And then you have to take the mean value, which is given here, 2008, and then take the standard deviation to the after intervention. Take the means and standard deviation, take the t, and in the middle, and the bracket is your, what we call it, degree of freedom. Where is degree of freedom? Blah, 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 blah. Here, 29. And the t value here is, where is t? 2.230. And p value 0.034. Okay, so why do you have to report this standard deviation even though you want to compare the means? So the purpose, the functions of standard deviation to tell you when you estimate this variable, how large is your variance, how large is your error made in estimating this. So people want to see smaller error, smaller amounts of standard deviation. If let's say your standard deviation is huge, means that in estimating this, you are incurring huge error. Okay, that's why we want to see the standard deviation. Okay, now next. Oh, wow, you have about 1 minute full. You have about half an hour more. Okay, cool. We have 21 slides. Okay, ANOVA. So ANOVA is the next chapter, which is chapter 12. What is ANOVA? ANOVA is the analysis of variance. The short form is ANOVA. So there are two functions of ANOVA for your information. The first one is that it can compare the population variance, of course, because we are talking about ANOVA. And second is it can compare population mean. Okay. Previously also you compare the population mean, right? Okay, let me see what is the function, the advantage of ANOVA. Okay. In one sample test, you just take the population and then take the sample, and then the mu you compare with the sample mean. In two sample, you have two tests, you have two sample, sample 1 and sample 2. You want to compare the means are equals or not. You are comparing just two mean from two population, right? This is the sample. So the population is somewhere here. I don't want to write it. In ANOVA, you can compare the means of many sample from many population. It's not just two. You can compare X bar 1, X bar 2, X bar 3, blah, blah, blah. So ANOVA can compare all these things. Previously, they can only, the maximum, they can just compare two sample. Now you can compare more sample, more than 3 even, okay, for ANOVA. Some people think that because we are talking about analysis of variance, so we can all only look at the variance, estimate the variance. No, ANOVA can also compare many means, okay, many population means. Okay, you will learn this later. So I'll just give you some introduction about ANOVA, right? So how to use the what we call SPSS. Everything is there. You should be able by now. You should be able on how to do it. So analyze. Oh, what do we need? I forgot. Categorical independent variable with 2 or more outcomes. You can have male or females. You can also have education like bachelor, master, or degree, PhD. You can even have more for ANOVA. It gives you more flexibility. Previously, you can only have 2 outcomes. Now you can have more. And 1 continuous dependent variable. Steps. Analyze. And then compare means. And then what else? We have to click on one-way ANOVA. So basically, there are also 2 ways ANOVA, but you are not covering it in your syllabus. So just look at one-way ANOVA. So now, next, what should we do? Move continuous dependent variable. In this case, we are talking about waste amount before intervention into the dependent list. What else? Then move the categorical independent variable. In this example, let's take, instead of age or no gender, we take education into the factor. Okay, so if you look at here, I bold the factor, means that it is written there. Next, click option. Can you see option here? Okay, put it here. What do we have in option? So in statistic, you can take descriptive, homogeneity, Brown test, what else? Welch, and then What else do we have? And under min plot, click min plot. For missing value, exclude cases and exclude cases, and it's by, yeah. So continue. Next, what else? Click post hoc. So you just click whatever written there, okay? You don't really have to know the mathematical background behind it. Just click it, okay? Because I will explain the how to read the result later on. So under post hoc, click Turkey. This is the test, the name of the test, the names of variant test. It's not Turkey. This is, yeah, Turkey. What else? Continue. That's it. The significant level. Okay, for us, we believe that significance should be 0.05, but in human size, they may change 0.05 into 0.10. So maintain it, maintain it. And then, okay, then you will have the test. Where is it? One way. So one way, you're going to have descriptive. This is the statistic. They will tell you how many bachelor, how many master candidates, PhD, blah, 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 the means, everything. This is just like what we call descriptive analysis. So, okay, you're going to have like a few more variables. You still even use, also still have like plots. Well, okay, so more variable because ANOVA have more functions. Okay, so let's see. Result. What do we want to see? Test of homogeneity or variance. So let's just ignore this descriptive. You know it very well by heart. Okay, so how to read it? Normally we're gonna look at based on trim min. You wanna trim it. Means trim like you have clear all the error, all the outliers and everything. So you have adjusted everything. So you want to look at the trim value. So let's see here. Because you talk too much, that's why. Can someone else talk for me? Okay.
Drink warm water.
I did. It doesn't really help because I talk too much. Okay, test of homogeneity of variance. This is the table, right? Okay, so how to look at it? So look at the significant value for Leuven test. Where is this Leuven test? Leuven test. Okay. Oh, I didn't really actually change this value 1.3. Yeah. So this is actually from the previous one. Okay. Hey, this I did. So I thought that, yeah, okay. So significant value under this test of homogeneity. So you want to look at the value of trim min 0.135. Okay, so 0.135. So the same thing, same rules. If the significant value more than 0.05, so you have to refer to ANOVA table, this one. Okay, if let's say if 0.05 or less, refer to robust test, robust table. So depends on your significant value here, 0.135. Is it significant or not significant? More than 0.5 or less than 0.5?
Significant.
Not significant, right? So it is what we call more than 0.05. So you have to refer to ANOVA table. So you don't really have to refer to robust unless you get 0.05 or less. So right now we have to refer to ANOVA. That's why the next result I show ANOVA. In your case, you may get significant. So you have to refer to robust. Okay, that's why I give you this condition. If it is not significant, you have to refer to this table. If it is significant, you have to refer to this table. Okay. So ANOVA, look at the significant value. ANOVA, significant is what do we get? 0.282. It is not significant, right? Okay, so this is the value 0.282. If 0, okay, you don't get this. If 0.05 or less means significant different, you don't get it. If more than 0.05 means your result is not significant. So this is just the rule. So you know it already. So here, our result is not significant. So the same rule applies to, the same rule applies to robust. If let's say the robust, you have to look at the whatever, you can use Wales, you can use brown, doesn't matter. So you just have to check whether it is significant or not. If it is significant, means that you have significant difference. If it's not, then not. So it's up to you. Some tests for brown, it gives you a significant result. For Welsh, it gives you a not significant result. So you have the freedom to choose which one. But for our case, we are looking at the ANOVA, which is not significant. Okay, now this is how you want to read the result, right? This one. Next table, multiple comparison. Okay, in ANOVA, you are given so many tables. So how to read them? So multiple comparison table, look at this table only if there is a significant difference in the ANOVA. Okay, we don't have a significant difference. We got 0.28. So you don't really have to look at it. You will look at it if, let's say, you got a significant value. So here, ANOVA is not significant. So if let's say ANOVA result is significant, so you will see this asterisk, like a star, in the column label as mean different. Where is it? So here, if let's say your ANOVA here is maybe 0.01, okay, so in this column multiple comparison, so in the mean difference you will see star something star. It shows that significant difference between the educations and what is our variable? Education and what? Education and what are we comparing?
Amount before intervention.
Amount of waste produced. So you will see the difference. Maybe sometimes people think that, well, those who are in higher level, PhD, maybe they are more concerned about it, so they may produce lower amounts of waste compared to the bachelor. So you will see star after the number, next to the number. Okay, so right now we don't have any star. Definitely your ANOVA is not significant, so you don't have to look at it. And then you're going to have homogeneous subsets, and you're going to have mean plots. So you can just ignore it. This is just to double confirm of your result. So you don't really need it. Okay. Okay, next. This is how you want to interpret it. This is how you want to put it in your paper. Okay. So how you going to say it? A one-way ANOVA between group analysis of variance was conducted to explore the impacts of education. Are we talking about education? On the amounts of waste produced. So I just put the short form. You can just complete the whole sentence. Education is divided into a few groups. You can say education is divided into three, like bachelor, master, and PhD. You can just put it. I made it last night, so I was so sleepy. I just put simple words. There was no statistically significant difference at the p-value, which is less than 0.05 level, in waste amount produced for different level of education. So you have to take the F. So in ANOVA, we don't use T. So that's why you see we are using F. Okay, F distribution. So previously we are using T, but ANOVA we are using F. Okay, the same function. And then here, degree of freedom. Where is it? Where is ANOVA? So we are using F. Okay, so you can see that how many degree of freedom do you have? You have 27. So you put these two together. So in the bracket after the F or after the T statistic, you have to put the degree of freedom. In ANOVA, if let's say you're going to have more groups, you're going to have more different degree of freedom. So put them all in the bracket. So this is the bracket here refers to degree of freedom. So what is the value of your F? The value of your F is 1.326. Okay, 1.326. And which is, we got it, where is it? We got it didn't significant. So yeah, but this is how the you can put p value bigger. This should be bigger actually. Should be bigger than 0.05. Should be. Because previously it is equals to 0.05, so I will put equals. But I have changed the data set, so yeah. If you found this star in your result, in your what result? Multiple comparison. you have to add this, like post hoc comparison, which is this one, this post hoc test. So post hoc comparison using the Turkey test indicated that the mean blah 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 significance. So what are the significance? So if let's say master and PhD are significant, so put the means of master or bachelor. So they will tell which one is significant from which one, bachelor degree with master or bachelor degree with PhD. So you put the mean and standard deviation. Okay, that's how. If you get a significant result, if not, then you can ignore this. So this is just the normal standard because you're going to have different data sets or you're going to get different results. So I put all the possible results. Okay, so far so good. We have less than 10 minutes. Okay, we have 21 slides. Okay, chi-square. So this is actually the last chapter, chapter 15. Okay, wow. Okay, chapter 15. We call it non-parametric methods. There are, whatever we have learned before is called as parametric. The last one is non-parametric, and there are reasons why we call it non-parametric. I don't want to explain now. So under non-parametric, you have goodness of fit. Okay. So and goodness of fit can be should use chi-square test, and independence also will use chi-square test. We call it chi-square, not chi, whatever. It's chi. Okay. So make sure that you know how to pronounce it. So these are the functions of them. I don't want to explain it. I don't want to really spend time on it. Okay. You gonna the same thing, the same format. I will tell you what is the rules to use this goodness of fit test, and what are the steps to generate the results. And once you have the results, how to read the results and how to interpret your output. Okay, everything is there. So you by now you should know how to do it by yourself. Okay, because I have done it like one by one. And next, and the chi-square you also have independent. Okay, the same thing. What you need steps in generating the result. The results you're gonna have like. There are actually more tables than this, but I didn't put it here because they are not that important. Okay, and then how you want to read the table and interpretations of the table in a better professional way. And the last one, okay, this is a correlation test. I put it last because we haven't covered this in our topic. We haven't covered correlation, but somehow, some people may think that they can use correlation. So when do you need to use correlation? When both of your variables are continuous, or both variable means that your independent and dependent are continuous or discrete, means number, not category. Or one of them, which is the independent, is dichotomous, like yes, no, head or tail. Yeah, you can use it. You can use correlation. So these are the steps, and these are the results. Okay, so they have some rules. If let's say you got the result of between 10% until 29, you call it small effects, and so on. So everything is given there. Okay, so for your information, in certain tests, like all the parametrics, okay, except for chi-square. Chi-square is not parametric. A correlation, one sample test, two sample test, PET test, whatever, they are called parametric. All the parametric method have a certain rules, certain assumption. Okay, so I put it here because in correlation, you really have to mention that you have done some tests to ensure there is no violations of assumptions of normality, linearity, homoscedasticity, whatever test. So in this workshop, if you look at the first one, yeah, I put it here. I ignore all the assumptions that you have to follow or to make before conducting the test for easy purposes. I just want to know to tell you how to use the SPSS, because for parametric you have to make sure that your distribution should be normally distributed. You remember that, right? We have learned in our chapter before. We learned that well, you're gonna have a bell curve shape, you're gonna have certain requirement. If it is not bell curve, then you're gonna use the test. All these things. That's why there are so many assumptions in conducting the test, but I just ignore it just for the sake of the workshop. Okay, and even though later on your data may not be normal, you just I just want you to know how to use the software. That's it. But in reality, if you want to conduct a study, if the data is not normal, you cannot use parametric. You have to use non-parametric tests. Okay. Anything else? Let me stop this discussion first. Or else everyone will have to spend a lot of time